Okay, last week I already completed part 1 of practical 3. Okay, now I will continue with the second part, okay, related to your question 2, okay, which asks you to load the weekly data set from ISLR packages. Okay, so you find that on this line, okay, we'll be using library ISLR to actually load the data. Okay, it has 1089 weekly returns for 21 years. Okay, the part A asks us to produce some numerical and graphical summary for the weekly data. Okay, and we are asked, is there any patterns that we can observe? Okay, so we just perform some descriptive statistics, okay, to study the relation between columns. Okay, first we just do some descriptive statistics. Okay, as we can see here that it's indeed 1089 rows. Okay, there are 9 columns. Okay, summary of them tells us that, okay, we have basically direction is the categorical data, others are basically either integer or numeric data. Okay, so the pairs plot would actually generate the scatter plot for all these columns. Okay, so let us have a look at the correlation. Okay, so any interesting things? Okay, so all this over here seems to be not related at all. Okay, except for this one seems to be a little bit related. Okay, so in order to learn this numerically, we generate the correlation matrix, which we find that basically except for, okay, this volume and here it's related, all others are basically less than 0.5, okay, plus minus. So okay, we don't see much correlation. Okay, only year and volume are related, other no special patterns. Okay, so that's more or less okay, part A. So now let us go to part B. Okay, for part B, right, okay, we need to first create the training data. Okay, we are told that to use period from 1990 to 2008. Okay, so now let us go to question 2. Okay, and okay, so all the data which is less than 2009, okay, actually are from 1990 to 2008. Okay, and then this is the training data. This is the Y, okay, of the sorry, this is the testing data or validation data. Okay, the X portion, okay, direction dot 0910. Okay, this is the validation data. Okay, Y. Okay, and then as we have learned during practical 2, okay, we need to use a generalized linear model in order to generate a logistic regression. Okay, as you can see here, okay, the one I highlighted here, over here, okay, this one. Okay, when we want to try the logistic regression model, okay, previously I've tried out. Okay, if I try everything, it will tell me that it will fail to converge. Okay, so I have to find what is the cause. Okay, so I I realized that okay, the key is the data in today okay will cause the algorithm not to converge. Okay, that is why okay you will find that I need to remove. So there's a negative sign here, remove today. Okay, and we would know that year okay is just something like an index, so it shouldn't be affecting the training, so that's why it's also removed. Okay, so now we'll try to build the model. Okay, so this is the construction of the model. We can find that okay, except for the intersection which is having some significance, seems that except for leg 1, others okay not really significant. Okay, even the correlated volume is not very significant. Okay, so that's the answer for part B. Okay, now let us proceed to part C. Okay, so for part C, right? Okay, we are asked to compute the confusion matrix and accuracy measures of the validation data. Okay, where the validation data is actually 2009 and 2010. Okay, so we'll just start from here, right? Okay, and then go up until here. Okay, so the solution is more or less something like this. Okay, first we perform the prediction okay using type response in order to obtain the probability estimate. Okay, after that we use if else. Okay, so if the probability is actually larger than 0.5, then we will consider it to be an up. Okay, otherwise it will be considered down. Okay, so the confusion matrix can be constructed by comparing the predicted values okay and the actual values. Okay, so we can see that we have 31 down and 17 up, which is predicted correctly. Others okay over here okay they are wrongly predicted, so that's why we find the accuracy to be very low. Okay, and finally we can perform calculations based on the formula we learned during lecture okay of the error rate okay, which is just a complement of accuracy. Okay, the recall down and up are actually just the precision and specification. Okay, and others are the PPV and MPV, right? Okay, so that is all we have for part C. Okay, now let us look at part D. Okay, now we are asked to fit the logistic model with leg 2 as the only predictor. Okay, so okay, the whole process is the same. Okay, we are going to use back the same we're going to use back the same training and testing data. Okay, so we'll find that the code is more or less the same. I just rename the model to from LR.M to LR.M2. Okay, so as we can see that okay, the logistic regression analysis on direction okay as opposed to against leg 2. Okay, all these formulas are more or less the same. Okay, we find that okay, accuracy improves slightly. Okay, so reduce rate I mean the error rate is slightly reduced, but that doesn't really tell us anything. Okay, all these are of some we more or less should be expecting it. Okay, because all these are stock data, and stock data theoretically shouldn't be predictable. Okay, otherwise everyone can get rich, right, by predicting the future stock price. Okay, finally we are asked to play around with other variables. Okay, so over here I just try to see whether the one which is predicted earlier to have some statistical significance, okay, lag 1, okay, and see how it behaves. And to my surprise, okay, I find that accuracy is actually even lower. Okay, so significant, okay, maybe okay, if it's not very significant, okay, sometimes it may not be statistical meaningful. Okay, so that is end of question number 2, right? Okay, so you can definitely play around with other variables, something like such as volume, right, and see whether it works or not. Okay, but anyway, I'll just stop here.